Question 9. Copy and complete the table of values for y is equals to 3 sine x plus 7 sine x for 0 degrees is less than or equals to x, less than or equals to 180 degrees. Oh, we have a table there. B. Using a scale of 2 cm to 20 degrees on the x-axis and 2 cm to 2 units on the y-axis, draw the graph of y is equals to 3 sine x plus 7 sine x for 0 degrees is less than or equals to x, less than or equals to 180 degrees. C. Using the graph, find the I value of y when x is equals to 150 degrees, II range of values of x for which y is greater than 0. Solution. Now, first, we were asked to complete this table, to fill up this table using the equation provided. So I'm solving A now to complete this table using the equation provided. So I'm going to divide this into 2. That will be easier. Now, first, we are given that y is equals to 3 sine x plus 7 cos x. So we are given this 3 sine x plus 7 cos x. Now, let's start with this. 0 is fill up. We have to fill up these values of y. Now, values of x are already filled up from the table. So we have values of 0 here. This one is filled up. That is value of x. When x is 0, y is 7.0. Now, when x is 20, so let's do that. When x is equals to 20. Now, what will be the values of y? So our y, we now say our y will be equals to 3 sine 20 degrees plus 7 cos 20 degrees, because we have x here, we have x here. Now, when you solve that, if you get 3 times cos 20, I'm just going to use 3 decimal place. So 3 times cos 20 will give us 1.026 plus 7 times cos 20, still to 3 decimal place, you have 6.578. When you add up that, you have 7.6 approximately. So 1 decimal place. Why am I using 1 decimal place as my answer? If you did approximation very well, if your question, like in this case now, is given to you in 1 decimal place, so it's advisable to return the answers back in 1 decimal place if it's not specified what decimal place you're to return it. So we have that. Now, this is what we have. That is for A. Now for B. Okay, we still continue. We are still solving A to fill up everything. So we have solved for 20 where we have 7.6. Now for 40, when x is equals to 40 degrees. When x is equals to 40 degrees, our y will be equals to 3 sine 40 degrees plus 7 cos 40 degrees. Cos 40 degrees. So you have that. Now 3 sine 40 degrees will give us 1.928. Just multiply 3 by sine 40 degrees. You have 1.928 to 3 decimal place. Plus 7 times cos 40 degrees will give us 5.362. Still 3 decimal place. Add up that, this plus this, you have 7.29. Remember I said we should take it to 1 decimal place. So take this to 1 decimal place, you have 7.3. So 7.3 is our answer for that. Next, when x is equals to 60 degrees, we have just finished 40 degrees. Now our y will be equals to 3 sine 60 degrees plus 7 cos 60 degrees. So when you do that, 3 times sine 60 degrees will give us 2.598 plus This is 8. 7 times cos 60 degrees will give us 3.5. When we add that up, we have 6.098. So approximate that to 1 decimal place, you have 6.1. What I did was that actually I'm interested in this 1 decimal place, 0. So the number close to that 0 is 9. So 9 is rounded up. If I round up 9, I will get 1. So 1 plus this place of 0, you have 1. That is why I'm having 6.1. So if you have to look at approximation again, I will advise you to do. So this is for when x is 60 degrees. Now let's go to the next one. When x is 80 degrees, that has been done for us. So we move on to 100 degrees. So when x is equals to 100 degrees, when x equals 100 degrees, y is equals to 3 sine 100 degrees plus 7 cos 100 degrees. Cos 100 degrees, that will be equals to, now 3 times sine 100 degrees. 3 times sine 100 degrees will give us 2.9544, 4 decimal place now. Then 7 times cos 100 will give us minus 1.2155. This is 5. So when we deal with that, remember plus minus is minus, so 2.9544 minus 1.2155. When you subtract that, you have 1.7389. So approximately to 1 decimal place, you have 1.7. So that is the value for when x is 100. Now let's move on to the next one. Want to use that to do something else. Okay, let's move on. When x is equals to 120 has been done for us already, so let's move to 140. When x is 140, we have 140. When x is 140, now our y will be equals to 3 sine 140 degrees plus 7 cos 140 degrees. 140 degrees. That will be equals to 3 times sine 140 degrees will give us 1.928 plus, and remember this will be a negative since it's more than since it's up to 100 and above. So 7 times cos 140 degrees will give us minus 5.362. So we have that. Now by the time we solve that, this is plus minus become minus, so this minus this, by the time you do that correctly, you have minus 3.4. Minus 3.4. So you have minus 3.4. Now let's move to the next one. For 160, we have also to solve that. When x is equals to 160 degrees, when x 160 degrees, our y will become 3 sine 160 degrees plus 7 cos 160 degrees. When we do that, 3 sine 160 degrees, that is 3 times sine 160 degrees, you have 1.026 plus, remember, 7 times cos 160 degree will give us a negative, so minus 6.578. So when we solve that, this is minus here, so when you solve this, you have minus 5.6, approximately to 1 decimal place at once, 5.6. Now we move on again. Let me extend this a little. When the last one, that is for 180, when x is equals to 180 degrees, your y or our y is equals to 3 sine 180 degrees plus 7 cos 180 degrees. So that will be equals to, now our 3 times sine 180 degrees, you know that sine 180 degrees is 0, so 3 times 0 is 0. So we have plus 7 times cos 180 degrees, or you know that cos 180 degrees is minus 1. So 7 times minus 1, you have minus 7. So when you solve the 0 plus minus 7, or just say 0 minus 7, since plus minus is minus, so 0 minus 7, you have minus 7. Remember, we are using one decimal place, so I'll just attach 0.0 there. So we have this. So with this, we have been able to show working. Don't just go and fill up this place without showing working. There's actually some marks given for showing the solving, how you were able to fill up the table. Don't just go and fill up the table and you expect to get a full mark. You may not actually have that full mark. So we are going to fill up the table. We have done the calculation already. So for us to collate these values, so we fill in these tables. So we complete the tables. We are going to do that now. Okay, I have copied down this table. We have recopied this table down here. So I'm going to fill up these tables. For values of when it was 20 degrees, we got 7.6. When it was 40, we had 7.3. Now when it's 60 degrees, we have 60 degrees here, we have 6.1. For 80 degrees already filled for us. For 100 degrees, we calculated we had 1.7. For 140 degrees, we have minus 3.4. Then for 160 degrees, we had minus 5.6. And for 180 degrees, we have minus 7.0. So that is what we have. So with this, we have been able to answer the first part of the equation, to copy and fill up this. Now the B part of it says, using a scale of 2 cm to 20 degrees on the x-axis and 2 cm to 2 units on the y-axis, draw the graph of y is equals to 3 sine x plus 7 sine x for 0 degrees is less than or equals to x, less than or equals to 180 degrees. Okay, I have a graph paper attached here. Hope you can see the graph paper. Now this graph paper provided by WAEC, NECO and SSCE. Now this particular graph is drawn in 2 cm, which is about 10 holes here. That is 2 cm, which is 10 holes here. Now these are drawn in 2 cm, so our work is almost done. Now remember that on the x-axis, we are asked to use 2 cm to represent 20 degrees. So if I place this somewhere here, if I place my center here, let's look at that. If I place my center here, let's do it together. If I place my center here, we'll count from here down to this place, maybe hopefully this place, so that we can get 180 degrees using 2 cm. So that will be 20. This is 22 cm, yeah. That will be 20, 40, 60, 80, 100, 120, 140, 160, and 180. Okay, that will not work the way we are going, because this is 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay, we can actually use that. We can use up to this place, 180. So if we shift this, let's shift this somewhere here. Let's shift it here. Let's take the 0 to this point. So let's check that. 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay, this is better now. So if you place the 0 here. Now let's look at, that is the highest value here is 180 for x axis. This is x axis. Both for, we don't have any negative value for x. That is why I can use here. I can use here since we don't have any negative value for x. So since there is no negative value of x, I can use this point. So we don't have any negative value of x, so I can use this point. Now, since we have negative values of y, I can't use here because I will need negative value. That will be below this point, give us negative value of y. So let's look at that of y. Now the highest value for y, for the positive, which will be up now, the highest value, if you check through this table, you find out that the highest value is some 7.6. 7.6 is the highest positive value, 7.6. So if you get up to 8, this will cover this. So let's check that. That will be, remember we are asked to use 2 cm for 2 units. So this is 2, 4, 6, 8. That is okay. That will cover that. 8 will cover up to 7.6. So that is okay. Now let's check. We are just trying to where to position our zero, our center here, the origin, so that we don't make any mistake when we rule. Now let's look at the negative side. For the negative, the highest of the negative in terms of just the value, not minding the negative sign there. So we have 7 here. So if we use the same thing, this is 2, 4, 6, and 8. So I'm going to take this up a little. Let me take it somewhere here. I'm going to take it up, so that because I already have 2, 4, 6, 8. So that will be okay for the positive. For the negative, now I have 2, 4, 6, 8. So it is okay because I have 7.0. So this is okay for the negative. Let's take it here. So this will become our origin. So we can rule that. So get a better ruler, maybe a long ruler, but I'm just going to use this. This is what's available now as of the time of making this video. This is what I have for this video. Since I didn't actually prepare to plot a graph, but I say, okay, let me just do it. So I'm going to rule this, use this to rule it. But get a better ruler and rule it. So I'm just going to rule this. One more thing, when you're ruling, don't place it on the line. When you're ruling, don't place it directly. Don't place your ruler directly on the line. Place your ruler a little away from the line you intend to rule on. So a little away so that you can rule directly on that line. So I'm going to do the same thing. That is for the x origin. So this is for the x origin. Now you can use a pencil, please, when you're plotting a graph. Use a pencil. I'm using pen so that it will be visible enough for you to see. So do the same thing here. Place it, rule. Do that for this side. So I'm writing, make an arrowhead. So this is my x-axis. This is my y-axis. Okay. Now, since we have done that, the next thing is to label our axis. So I'm going to come here. This is my 20 degrees. 20 degrees. This is 40 degrees. This is 60. Remember 2 cm to 20 units. This is 80 degrees, 100 degrees, 120 degrees, 140 degrees, 160 degrees, and 180 degrees. So we have that 180 degrees. So let's do the same thing to this side. This is a +2. That is for the y-axis. This is 2. This is, remember, this 2.0 like that. This 2.0, 2.0, 4.0. So it's the same thing. So this is 4. This is 6. This is 8. I think 8 is okay because we have up to 7.6. You can continue if you wish to. This is -2, 2.0. This is -4. This is -6. And here we have -8. So we have -8 here. -8 at this point. Now we write our scale. Let's write the scale here. Or we write the scale and we also write the title. This is a graph. There's already something written here. Graph of x against y. That is the title of the graph. Now on this is the x-axis. There is x-axis here. So on the x-axis we use 2 cm represent 20 degrees. Here also on the y-axis, 2 cm represent 2 units. Now indicate the question number you are answering that of. So that we are answering question 9b. This question 9b that asks us to plot a graph and answer some questions from there. So question 9, this question 9b. Now we are going to plot this graph now. Since we already prepared all this, the next thing is to plot our graph using this values. So at this point we have, this is the origin, 0, 0, this is the origin. Now when x is 0, that is at this point x is 0. From the table now, we are using the table to plot. When x is 0, y is 7. So we get to this place. If this is 6 and this is 8, midpoint in between these will give us midpoint in between, just for you to count. This is 1, 2, 3, 1. If you can see very well, this is 1, 2, 3, 4, 5. So in between is 7. So this point is our point 7. So this is our point 7. This is our point 7. So that is a point 7. Now when x is 20 degrees, so this is 20 degrees. When x is 20 degrees, y is 7.6. 7.6. This is 7. This is our point 7. At this point we have point 7. Now 7.6. If you go up a little, this is 7. This is 6.1, 6.2, 6.3, 6.4, 6.5. Now this will be okay. This is actually 7. This is 7 because we are taking 2. This is 6.2, 6.4, 6.6, 6.8, and we have 7. So each of these holes represent 0.2. Each of these holes represents 0.2 for the y-axis, 0.2. X-axis, we don't actually have problems since they are all whole numbers. So each of these holes represents 0.2. So this is 7, 7.2, 7. This is 7. This is 7, 7.2, 7.4, and 7.6. This is 7.6. At this point we have 7.6. So this is 7.6. So I'm going to plot that. This point 7.6. I'm going to plot that point 7.6. Now we go on 7.3. When it's 40 degrees, is 7.3. Don't forget this is our 7. It's our point 7. 7.3. This is 7.2. Remember it's 0.2. 7.2. So that is 7.2. Now in between, this is 7.4. So in between 7.4 and 7. This is 7.2, 7.4. Okay, this is 7, 7.2, and 7.4. So in between 7.4 and 7.2, we have 7.3. So it's going to be halfway here in between. It's going to be halfway in between. Now the next one, we move on. It's going to be a curve. It's going to be a kind of a curve. It's going to be a cosine sine graph, which is showing a kind of a wave curve. Wave graph. So we move to the next one. When it is 60, is 6.1. This is 6. Remember, the next line here give us, this is 6. The next line here will give us 6. The next hole will give us 6.2. So, and we need 6.1. So that will be in between. That will be in between. Immediately after 6, we have 6.1. That is in between 6.2. So the next one we have 4. When it's 80 degrees, we have 4.2. 4.2. These are 4. 4.2. This is 0.2. This is 0.2. 4.2. Each point, like I said, is 0.2. Each point is 0.2. So this is 4. This is 4.2. 4.2. Now the next one, when it's 100, is 1.7. When it's 100, is 1.7. So this is 100, 1.7. Now in between this, from 0, in between 0 and 2 is 1. So we just, for us to count 5 holes, 5 lines. 1, 2, 3, 4, 5. So that is our 1. Our 1 is here. We are looking for 1.7. So don't forget, each hole is 0.2. So 1.7, this is 1, 1.2, 1.4, 1.6, that is each hole. Now the next line will give us, the next point will give us 1.8. So in between 1.8 and 1.6 will give us 1.7. That is going to be this middle here. That is going to be that middle. Okay, so we have that. Now the next one we have minus 0.9. Minus 0.9. So we go down, we are going down. Now when it is 120, it's minus 0.9. Now don't forget, the same thing we did above, we can do that below now. So between this zero and this point is, so we look at in between 0 and minus 2. In between, you can count that 1, 2, 3, 4, 5. So we count 1, 2, 3, 4, 5. So that is our 1. That is our 1. If you take that as well, you can count to 1, 2, 3, 4, 5. So this is our point 1. This is our point 1. Now remember, we are looking for 0.9, not minus 1. So this is 0.9. So let's take from the origin now, from this point now. So when it's 120, we take from this minus 0.2, minus 0.4, minus 0.6, minus 0.8, and we have 1. So in between minus 0.8 and 1, we have minus 0.9. In between here, at the middle, in between we have that. So we have that. Now the next thing we want to do now, to get minus 3.4 when it's 140. When it's 140, we get minus 3.4. So we have, this is minus 2 and this is minus 4. So in between minus 2 and minus 4, we have minus 3. So we just count 5 holes to get our minus 3. So 1, 2, 3, 4, 5. So we have this point. This is the midpoint because it's 10 holes. There are actually 10 lines. So I'm counting 5. When I count 5, I have where the first one will fall. So this will be our point 3. The midpoint between minus 2 and minus 4 will give us 0.3. Will give us minus 3. Will give us minus 3. Remember, we need minus 3.4. So remember, each hole, like I said, is minus, each hole is 0.2. So here we'll be having minus 0.2, the down below the graph, below the origin. So this is our 0.3, so that we have minus 3.2 the first line, minus 3.4 the next line. So at this point we have minus 3.4 at this point, minus 3.4 at that point. Just make asterisk, a kind of a star there. Remember, some people prefer to make a 0 there, but I prefer to use a star, asterisk, to point that place. Now the next one, we move on to 160. When it's 160, is minus 5.6. Now in between minus 4 and minus 6 is 5. So we are going to just count 5 holes. 1, 2, 3, 4, 5. So I have my 5th hole here. That will be my minus 5. That is my minus 5. If you also count here, 1, 2, 3, 4, 5. So this is my minus 5. In between here is my minus 5. Now I need 0.6. So minus 5. Remember, each hole is 0.2. So minus 5, minus 5.2, minus 5.4, minus 5.6. So I have exactly 5.6. So minus 5.6. So I have minus 5.6 down there. Now the next one I want to take now, minus 7.0. Now in between minus 6 and minus 8, you have minus 7. Minus 7.0 is the same as minus 7. So I'm just going to count 5 holes from here. 1, 2, 3, 4, 5. So this is my minus 7.0. That is minus 7. So I have that. Now the next thing here is to join these points. So you can use, if you have a flexible curve, you can use that to join them. If you have flexible curve, okay, we made a mistake here. This is supposed to be for 180. So let's just trace that line to 180. So this is a 180. So sorry about that, we made a mistake on that. So that's 180. So we have completed that. So you use your curve if you have a flexible curve, you can use it to join the line. But if you don't have, you can do it using a free hand to join them. So I'm just going to use a free hand to join them. You can also use a broomstick too. So I'm just going to use a free hand to join them. So I'm going to join them now, gently. So I'm joining them. Okay, make sure it's neat so that you can read the points correctly. I'm joining them. Okay, join them. We are doing that. Okay, it's not a straight line graph, so it's a curve. So I'm trying to make a nice curve. So I've been able to join the points just using freehand to join them. So you can try plotting this same graph and you master this concept. So I've been able to join that. Now, if we go back to the question, if you started this video with me, you probably had that question with you. Now, using the graph, we are going to use this graph. Find the value of y when x is 150. Find the value of y when x is 150. Now, when x is 150, let's take that this is 140 and this is 160. When x is 150, what is the value of y? So I'm going to get my point 150 here. So let's count. In between this is 150. That is half of this. So I'm going to count 5 holes. 1, 2, 3, 4, 5. So just know that each line here for the x-axis, each line for the x-axis is 2 point. So that five lines or 5 holes will give us 10 points. So we have that 10 degrees. So each line is 2 degrees. Each line 2 degrees. So if I count each of them here, 2, 4, 6, 8, 10. Have you seen that? So 10 plus 140, I will have 150. So this is my point 150. This is my point 150. So from that point, I will trace it to the graph. I will trace it to this line, to this our curve. So I'm going to trace it to this our curve. So use a ruler or you trace it correctly. So I'm going to trace it. I will use a broken line to trace that so that you can see. I'm using a broken line to trace that so that you can see where it meets. Okay, so if you look at that broken line I used there, so it's meeting it at this point. It's meeting the curve at this point. Look at where it's meeting it. So it's meeting the curve at this point. Look at the curve. This is the curve. So from that point 150, when x is 150, is meeting it at this point. So I'm going to trace this point to the x-axis rather. So I'm going to trace this point to the x-axis or to the y-axis rather. So I'm going to trace it to the y-axis because this is already x-axis. So let's trace that to the y-axis to get the corresponding value of y. So if you look at it, let's move on. Use a ruler if you must. If you have a very good eyesight, I think you can do it without a ruler. So, but using a ruler makes it more accurate so that you don't trace another line. So I already have this. So I'm following that line. So follow that line. So this is the line I'm talking about. That is the line we have there now. That is the line. So I followed this line all the way to this point. So this is the point. This is the point. So I'm going to remove that now. This is the point we are going to read. So I'm going to read this point. This point. So don't forget each hole is 0.2. So when you plot that from here, I plotted it. Each hole is 0.2. Each hole is 0.2. So this is 4.2. This is 4.6, 4.4. So you have minus when. So you can put it somewhere here. When x is equals to 150 degrees, y is equals to now let's look at that. Our y will be equals to, so we trace that this is minus 4.2 minus 4.4, so we have minus 4.4. Now, another person may have minus 4.6, another person may have minus 4.5. But the fact remains is that you are all at the range of 4.4. So what we are having, maybe sometime, while you were joining the lines, sometime the graph, while you were joining, you were using a free hands to join, or you were actually using a French curve to join, and while you were joining, maybe there was a shift along the way. So the examiner understands this. So there will be a benchmark of 4 points. So whatever you now have, 4.1, 4.2, 4.3, 4.4, 4.6. So if your neighbor is having 4.5 and you are having 4.4, there is actually no much difference. You will still have your full mark, provided your graph is correct. What you plotted is okay. So we have that. So this is our value of y is minus 4.4 based on our own graph. Don't go and copy someone else's graph value, because when the examiner will check, most time they want to check from your own graph and grade it. So if your reading is correct based on your graph, you have the full mark. So that is the answer to this question. So when y, that is for I, this is for c, that is for c. So this is the c part of the question. So we are answering it on the graph. The C part of the question asks us to find the value. We have actually answered the B part of it, still on the graph. Now from our graph, we're using to answer the C part of the question. So when x is 150 degrees, our y is minus 4.4. Now the range of values of x for which y is greater than 0. Which y is greater than 0. Now, for y greater than 0, our range of value of x, that is for I. Let me make a statement here. The range of values of x for which y is greater than 0 is x less than 113 degrees. So you can also get that from the graph. So when x is greater than 0, so the range of values of x is 113 degrees. So how do I know that? If you look at this, from zero, you trace it. When x is greater than 0, that we are looking at this top. When it's greater than 0, so you trace it to this point. You see this point this point. This is the point of x you have. This point of x. So if you trace it, you know that in between you can count. This is 2, 4, 6, 8, 10. So we add that 110. This is 110. Now 110, let's count again. 2, 4, 6, 8, 10. So that is 10. We add that to 100. This is already 100 here. So 100 plus 10 is 110. So this is 111. So we have that. So that is around 113. So roughly 113, because this is not up to, this is 2. This is not up to 4. So it's in between 4 and 3. In between 4 and 2. So in between 4 and 2. So that is 3. So we have x will be less than 103 degrees. So if you have a problem while you're going through this, please feel free to reach us and we'll answer your question.